So in 8.1, we start to find out that we've been really sheltering ourselves from the type of equations that exist out there. And so the very first thing we'll do here in 8.1 is just a quick review of a process that we've been using for a while now for solving quadratic equations. But we will quickly learn that this process is not the only process, as many equations are not solvable this way. So the process we know and have used up to this point is referred to as a zero factor property. The idea that you can take an equation with higher powers of your variable and you can set it equal to 0, factor it, and end up at the point with linear factors that you can then set equal to 0. So this is our factoring method. So a couple quick examples, just as quick reminders how this works. By no means is this every single possible type of equation we could see that would factor even, but just as the basic processes. We've got this equation here where we've got a y squared term, a y term, and a constant. So we can recognize that as an equation that we want to get into the form of equal to 0 and then factor. And this is just what we call the easy case number game, where you're looking for two binomials that we know both start with y, two numbers that multiply to 15 but add to -8, which would be -3 and -5. And then we can create those individual linear equations that give us our two solutions, 3 and 5. Both of those are solutions to that equation. Now, for the second example, we see a very similar setup. If we move the 15 over, notice here there's no GCF, so that means this 2 is stuck out front, meaning we can't use the easy case number game. Instead, we need to use the bottoms up approach. So that's where we take our 2 times our 15 off to the side here. 2 times 15 gives me 30. And then I want two numbers that multiply to positive 30, but add to negative 13. So that'll be a -3 and a -10. Now, those numbers -3 and -10, we then take the 2, what we call the a value, and we think of them both as fractions over the 2. Then we can write our binomials below here with the y, but if we can, we definitely reduce. So that -10 over 2 reduces to a -5. 3 over 2 did not reduce at all. And then any of the factors, or any of the values that did not reduce, have a denominator, and this is where we call it the bottoms up. That 2 comes up and gives us the factor of 2y minus 3. And then the other factor, which that did simplify, so there's no bottom to bring up, of y minus 5 equaling 0. And so then those are our two equations we can create. 2y minus 3 equals 0, and y minus 5 equals 0. So 2y equals 3, so y equals 3 halves, and there, just y equals 5, and that would be our two solutions, 3 halves and 5. So there are other factoring methods like difference of squares and grouping as well, but the point is this approach, no matter what you're looking at, is the idea of setting equal to 0 and then using factoring methods. But that only works if the equation factors. So we're going to be looking at other processes that we can use when we're given an equation that does not factor.